Hi. So, past couple videos, we looked at how a graph of parabola works from vertex form. We compared that to the graph of an absolute value equation. And then the last video, we talked about domain and range of a parabola, and that also related to absolute value. And then we took this parabola, this particular one that we have drawn out in our graph, and we expanded it. We'll call it expanded. It kind of did the math, solved for y, and got it into standard form. We saw that in standard form, the y-intercept is easily seen, and the x value of the vertex, the 1, can pretty easily be calculated using negative b over 2a, negative 4 over 2 times 2. Now, I also want to start with the standard form and go to the next form of the equation. So here's two forms of the equation, vertex form and standard form. The last one is factored form. And this is why we've been learning all we've been learning in chapter 8. So here's the same equation. It's the same one we had here a minute ago, standard form. Here's the equation, standard form. And now we're gonna factor it. So we're gonna go to factored form. So it looks like we have a greatest common factor in this case. That's that same 2 that we've been looking at for a while. That used to be the a value in both vertex form and in standard form. So here we have 2 times x squared minus 2x minus 3. And hopefully this factors. Now, y equals 2 times, let's see, a 3 and a 1. So x 3 and x 1. The 2 is negative, so that's a negative 3 and a positive 1. That is going to make the negative 2. And it does factor, thank goodness. That's why I chose it as an example. Now, notice that this factor, this negative 3, produces this positive 3 over here in the graph. That's because this positive 3 produces a y value that's equal to 0. Now, if you think about this, so this, by the way, is called, this is factored form. Factored form. Now, when we were playing with this in class the other day, some of you were noticing the y and the 3, but weren't understanding why it was opposite. So if you think about this equation, by the way, this 2 is the same a it's been all along, right? The 2 is the same it's been. If you think about this equation, in order for y to equal 0, either this factor has to be equal to 0 or this factor has to be equal to 0. So in order for those values to exist along the x-axis where y equals 0, right? Y equals 0 along the x-axis. Either this factor has to be 0, which a 3 is what's going to make this factor equal to 0. That's why that 3 is an x-intercept, because 3 in the position of x makes this term 0. And this negative 1 over here, x negative 1 plus 1 would make that term 0. So the zeros, we call this zeros, or we call it roots, or we call it x-intercepts, come from seeing what's happening in factored form, okay? Now, you might think of the next thing we're going to look at, which are equations. Equations very often will, instead of having a y, they'll have a 0 over here. So you'll have this thing to solve for 0. So we'll do that in the next video. All right. Now think about this, factored form. Let's put this into something that makes sense with some letters. Y equals a times x minus m times x minus n, where n and m are x-intercepts, also known as zeros or roots. All right, so n or m are x-intercepts, known as zeros or roots. All right, next video we'll take this idea into an equation. All right, we'll take this idea into an equation in the next video.